Welcome to the Future of Life Institute podcast. My name is Gus Docker, and I'm here with Samuel Hammond. Sam, welcome to the podcast.
Thanks for having me back.
Great. All right. Maybe for the listeners who don't already know you, you could introduce yourself.
Sure. My name is Samuel Hammond. I'm an economist at a think tank in Washington, D.C. called the Foundation for American Innovation, kind of a boutique tech policy shop. And prior to that, I used to run social policy for the Niskanen Center.
Great. All right. Let's start with a very important question. Is AI progress plateauing?
I certainly don't see any signs of that. I think people have a bit of impatience, right? A lot of worries about, somehow GPT-4 leading to some kind of hard takeoff, and we had 6 months to prepare. Maybe that was a case of the boy who cried wolf. But the fact of the matter is that the scaling continues. We've had a hardware bottleneck. Last year, NVIDIA produced maybe 500,000 H100s. This year, they're producing on the order of 2 million H100s and starting to roll out their next line of chips. So that bottleneck is just starting to alleviate. And as Kevin Scott from Microsoft said recently on an interview, all signs are that we're still on some kind of exponential curve, but it's one that we only get to sample every few years as new hardware comes in. And we've been stuck on a temporary plateau because GPT-4, of course, was a kind of, 2022 technology. And what we're seeing instead is a kind of catch up on smaller models that are now as performant as GPT-2 with a half or quarter of the size. But those algorithmic improvements are also being fed into bigger models. And when GPT-5 comes out later this year, or maybe early next year, we'll actually see for the first time, what looks like the sample from that higher level of scale.
So this might just be a question of us being in between models and people getting impatient.
Yeah, exactly. The way neural scaling laws work is, on some level, there's always diminishing returns, right? They're log normal. So to get a linear improvement in model performance, you do have to grow the data and compute and parameters exponentially. But we still have Moore's law and Moore's law-like trends running in the background with algorithmic improvements and hardware improvements. And so the exponential computing needs that we need are in some sense more linear than meets the eye. And so we're not on a true exponential where, we're on some hyperbolic curve where every model is going to be, as big a leap as GPT-2 to 3 or 3 to 4 was. But we are adding more nines to the decimal place, right? And that actually may contain a lot of really valuable information from the perspective of, getting these models to work better as agents, to be more reliable, to cross certain thresholds for, real life use cases. And that is something that we only get to do every few years because of these hardware constraints.
Yeah. And so the question is also, how far will this take us? You write about how LLM scaling will converge to human level intelligence. Is that because simply is that a limit of the training data because we only have human produced data?
Well, I think current methods based on training on human data will converge to human level intelligence. Of course, not like, in some ways the models will still be superhuman because they have, vast knowledge that no one human has and are able to sort of be a superposition of different personas and so on and so forth and think much faster. Like no human can just sit down and regurgitate a 1,000-word essay within seconds. But in terms of the core competencies of the model, the models are being trained on human data, so on some level they're being bound by the abilities and intelligence and reasoning capacity that is latent in that human data. That being said, there's obviously a potential for techniques to bootstrap ourselves out of that bound, right? In the same way that Alpha Zero, the chess playing AI, through unsupervised learning and soft play, was able to not just beat humans but become several standard deviations better than any human could ever be.
So how would self-play take us beyond the current training paradigm?
Well, we're seeing early signs of this already, right? So Alpha Geometry recently came out, a paper from DeepMind that scored near the top of the distribution of the International Math Olympiad, made a silver medal, and the way that model worked was sort of pairing, sort of a neurosymbolic approach, right? Pairing the kind of common sense understanding of Gemini and a large language model with search and the kind of Alpha Zero style reinforcement learning model over a formal language to actually verify the mathematical proofs. And this is sort of similar, I think, to how humans tend to how humans are inventive, right? Humans don't just sit down and, discover general relativity just by thinking harder, right? We have certain intuition, certain analogies. In the case of Einstein, his moment was the equivalence principle that, being in an elevator that's falling is sort of the same as gravity. And so how does that cash out mathematically in terms of space-time? So, large language models have that kind of analogical reasoning ability, that kind of semantic understanding, and that they're therefore able to make sort of really good guesses and generate ideas. And then those ideas have to then be verified, right, and checked against some ground truth. And so the models we have today are sort of pairing that tacit understanding with the ability to then search down different branches, check and verify, and then recycle that knowledge back and loop iteratively. And then, what has happened is, some of these models have already broken new ground, right? FundSearch from last year made progress on, 4 mathematical open questions. And so these models seem capable of generating a degree of novelty when they're paired with reinforcement learning techniques and search techniques. Now, the question is, then sort of the holy grail is, how do you set that up in a way that could be fully unsupervised and automated, and also applied to a more general reward function, right? And this is sort of the problem with general intelligence. We know how to make a Dota playing AI that can beat pros at a very complex real-time strategy game, but that's because there's well-defined rules. Real life is much more complicated. There's no one win condition. Evolutionarily, it was, reproduce and survive. But we can't really use that as a reward condition for these models. And so, the question is, how do you structure play environment such that the reward signals pull the model towards a more general form of intelligence rather than a more narrow?
And is this related to agents that you mentioned earlier also? Do you think to go beyond LLMs, we need to move towards agency somehow?
Yes, and partly this is also prerequisite to unlocking a lot of economic value. And so there's a natural tendency towards this area of research. The way LLMs are trained today is off of large corporate text, a lot of internet text, and a lot of that is sort of final outputs, right? You see the essay, you see the Wikipedia article, you don't see all the intermediate steps that went into writing that essay or that Wikipedia article. And so the kind of data we have are great for sort of zero-shot writing an essay, but not for the kind of incremental chain of thought that goes into producing something new.
I mean, on that note, how difficult would it be to screen record office workers for many thousands of hours and then training on that data? Or is that, I mean, maybe that's too naive, right? But something where you're gathering data about the processes leading up to a final output product and then using that as training data.
Yeah, that's why Microsoft released their Copilot laptop. Right? All these new products come with optional sort of recall features that will record your screen and pass it through a multimodal model to see what you're doing, and maybe, sort of like a supercharged paperclippy. But by the same token, that screen recording could be put on every employee at Microsoft's computer or Google and build an enormous data set of sort of multimodal data that includes recordings of employees' screens, keyboard inputs, mouse inputs, with, the semantic understanding that comes pre-trained into a language model. And that presumably has much higher signal data for how to be a code monkey, among other things, right? And so that's where I think in the near run, a lot of the energy is going towards, is finding new kind of data sources that encapsulate some of that planning and multitask understanding.
Where are people looking for these new kinds of data?
Well, like I said, like within, large corporations, I think in general, there's a realization that all data could be potentially useful. And so, everything should be recorded, and then we'll figure it out later. But the same could be true of manufacturing processes. One of the slightly non-consensus takes I have is that the US could have a substantial lead in AI vis-a-vis China, but the fact that China is the factory of the world and has so much industrial tacit knowledge embedded within their factories and manufacturing communities, that represents a latent source of data for training general purpose robotics, right? And we may develop the general purpose humanoid robotic platform, but that general purpose robot doesn't just, automatically a priori know how to assemble complex machine tooling or something like that. It the point of generality is it's able to then learn that on the fly with some demonstrations or some supplemental data. And so our innovation in bits could, in the long run, become China's innovation in atoms if they're able to then transfer that into their factories, because all those workers that they already have could be monitored either through, GoPro cameras or cameras on the ceiling, and absorb all that tacit knowledge and then imbue it into a robot.
If you take a smart person, you mentioned Einstein, for example, that person will be able to look at all data created, or not look at all data, of course, but look at some small set of the output of humanity up until that point, and then make progress beyond the limits of that data. So when should we expect AIs to get to that point where the kind of quality of the training data is no longer the limit? Here, I think we're beginning to talk about self-improvement, AIs doing AI research, that kind of thing.
It's a trillion-dollar question. So one of the critiques of large language models, large multimodal models, and transformers in general is that they will always be sort of within distribution. And I think there's something, the question is that also true of humans? Because, science progresses by, we stand on the shoulders of giants, right? And things progress one neural at a time. And it's a very incremental sort of gradient descent through knowledge is there have been some leaps forward, right? Aristotle, perhaps, or Isaac Newton, but we tend to be within distribution and then poke at the edges of the distribution based on the ability to receive sort of exogenous feedback from reality and feedback from other people in our environment. And so I've long thought that getting to that point where we can bootstrap something that can genuinely get a distribution will require some kind of multi-agent framework, because those different agents will provide exogenous sources of data and, being able to sort of check and balance the biases of a particular model and knock it out of distribution in the same way that, a band in a jam session could be thought of as, the different musicians prompting each other and inspiring new ideas that build on each other and collectively move outside of their distribution, because all their distributions combined sort of aren't perfect overlapping Venn diagrams. They have areas where they diverge.
Are you imagining a setup in which you have, say, one agent conjecturing a new scientific theory, and then a bunch of other agents critiquing that theory, and then they're making kind of incremental progress by criticism and then updating their models? Could we replicate the scientific procedure that humans are engaged in AIs like that?
Yeah, absolutely. I think there's already work being done in this direction, sort of automated hypothesis testing and idea generation. And, another way to think about this is, any scientific question is this enormous search problem. Maybe it's an NP-hard problem where, the time span of the universe wouldn't give us enough time to just brute force it. And, the human mind seems able to do things that seem NP-hard, right? That somehow we're able to just leap forward in the computation and get to the correct answer. And it seems like the reason that is because we have a series of inductive priors built into how we perceive the world that reduces the search space dramatically and makes it easier to find that needle in the haystack. And you see the same thing with some of these more prosaic applications of AI, where NVIDIA is using generative AI to beat the Shannon entropy bounds on information transmission, because we're not transmitting the bits fully faithfully. Instead, we're using the inductive priors of what a face looks like and what what every Zoom call has in common to reconstruct the data in a way that's vastly more efficient than if we sent it in a sort of lossless way.
Yeah. Is this meta-learning when you're talking about biases and heuristics and priors and so on? Are we talking about meta-learning there? And what is meta-learning?
So, meta-learning broadly is this idea that rather than prejudice ourselves into one particular learning framework, we could have a sort of meta architecture that is able to dynamically discover which learning algorithm is the best for a particular use case, and sort of search the space of learning algorithms one layer up before going down. There's probably some there, but I still tend to be of the opinion that scenarios where we stumble into some new architecture that breaks free of within distribution limits of current models, then just rapidly takes us to some new heights is unlikely. And that's partly because that doesn't seem to be how humans work. we have some degree of learning how to learn. Maybe a better analogy would be this debate over symbolic versus deep learning approach to AI. I think it's a bit of a false dichotomy because when you look at how humans process things symbolically, we don't seem to do it innately, right? Our mind is a kind of deep learning architecture. You can represent if and then statements within neural network, not the most efficient way to do that. But, humans struggle with 4-digit multiplication and a variety of other things. What we instead do is we use language to supplement and extend our cognition, because language is a sort of serial symbolic mode of processing. It's the classic Danny Kahneman thinking fast, thinking slow. And is the slow part of our brain really a module in our brain, or is it actually just language, right? And our ability to externalize thought and use that as a kind of external scaffolding, a kind of extended mind, to then give our heuristic ways of thinking a formal structure, right? And that's, we see hints of that with existing AI. There are approaches where we are going to explicitly put in some Python interpreter or some symbolic engine, but maybe with sufficient scale, we don't actually even need that. We just need the ability to serialize our thought and turn it into symbols.
Yeah, I guess this what we're talking about now is whether, say, agency or reasoning is something that's fundamentally different from what we're doing when we're training an LLM. And yeah, what do you think is the answer there? Is agency and reasoning something that emerges out of the training processes we're doing now, or do these things require something very different?
So we know how to make agents, right? Reinforcement learning. We have many RL agents, and then we know how to create sort of common sense reasoners, LLMs. And the open question is, how do you combine those two competencies? Agency seems driven by, classic sort of Carl Friston free energy principle, where we are organisms that are trying to model the world, and a sufficient degree of complexity and sophistication. We move beyond being a mere thermostat that is sort of, thermostatically adjusting the temperature based on the next time step of what the temperature is, to being able to model the world, model the future states of the world, plan for those states, and then we can start speaking of those kind of systems of having sort of beliefs and preferences and being able to take choices. The challenge, so one hypothesis would be that agency has been sort of slow to develop within these large language models because we're first of all, we're not using RL very much at all. We're using it sort of in the post-training phase. And secondly, the data itself is it's fitting a function for how to generate human text, but not necessarily how to model future states of the world and make decisions within that world.
Let's switch gears a little bit and talk about U.S. national security. You write that it is in the U.S. national interest to monitor frontier AI development. Why is that?
Because there's a lot of uncertainty, right? And, I have my own views. There are people who are much more certain in either direction. And I think a good epistemic process is to say, well, when there's this much disagreement, we can't really discount anyone's views. There could be a 10% chance that within the next 5 years, we develop some AGI-like system that rapidly bootstraps itself to superintelligence and is scary, powerful, and potentially decisive for the nation that is the first to get there, or not. Or maybe we do hit some kind of, maybe not a plateau, but more linear rate of progress. And, within that uncertainty, it's good to have option value. So within the existing regulatory approach that the U.S. has taken, we haven't passed any kind of comprehensive AI law, but with the White House executive order from last year, the Department of Defense has the authority to request disclosures and safety testing and red teaming from frontier model labs that train models above the 10 to the 26 flop threshold that they set. Those thresholds are liable to be updated over time. And, this is a very de minimis kind of oversight mechanism. It's just saying, if you're going to do a massive training run, and if you are one of the 3 or 4 labs that have building AGI as an explicit mission, maybe just let us know. And, let us have a sneak peek, because we don't actually know exactly what we're building and what its implications are. And having some kind of, break glass in case of emergency option could be really useful. And I think this is also something that should be acceptable to both the accelerationists, AI skeptics, and AI doomers. It's basically saying, we don't know who's right. Let's at least monitor and have some capacity to intervene if things go haywire.
Yeah, you're more positive when it comes to monitoring with using compute thresholds than other types of regulation. Why is that? Why is using compute thresholds for monitoring and then requiring certain disclosures? Why is that a kind of a minimal form of regulation?
Well, it's really more practical than metaphysical, right? And there's been plenty of pushback against compute thresholds per se, and I wouldn't recommend putting compute thresholds into statute, right? Because things can change really quickly, and it's actually good to have a degree of discretion in how we define these criteria. But the primary reason for the thresholds was to sort of triage oversight to the biggest players. There may be 3 or 4 companies on Earth, at least within our sphere of influence, that could train models that pass that 10 to the 26 threshold, at least today. And all those companies, when they're training those models, they're not training the 10 to the 26, music generator. They're training frontier generalist AIs. And so, maybe there is some better sort of criteria rooted in the scaling law literature. This recent paper on observational scaling laws that shows through a principal component analysis that there are a handful of parameters and variables within a neural network that reliably predict performance across a variety of benchmarks and perform better than just a naive sort of flop measure. So, maybe we should move towards that in the longer term. But, this is about moving quickly and having something that is clear, simple to understand, and achieves what the purpose is, which in this case is not to say that 10 to the 26 is some magic line, but that this is just a useful short-run way to proxy for the frontier labs.
Yeah, these numbers are definitely temporary, as you also mentioned in your writing yourself. At some point, it will get... What we really care about is model capability, and we can't really measure that directly, so we're measuring training compute instead. But at some point, you can train a very capable model for not that much money or using not that much compute. What do we do then? If compute thresholds are temporary, what replaces these thresholds?
Yeah, that's the other side of the practical consideration is if it is possible to train a dangerous dual use kind of model with a couple of consumer GPUs, then, oversight and enforcement is kind of, out of the question, right? And there's really no point in having an oversight regime, much less like a licensing regime for capabilities that people can just build themselves off the shelf. So in that world, one of the intuitions is that new capabilities will first be detected by frontier labs at scale. Karpathy had a recent Twitter thread where he discussed how, the performance of these smaller models is catching up, in part because you have to build the bigger model first to then generate synthetic data that is sort of disentangling reasoning from extraneous knowledge to compress it into a smaller model. We have good reason to believe that the warning shot from new capabilities will first come from the biggest models. And then, a clock turns on that is the countdown to when the similar capabilities become possible through open source or much smaller compute. And then we move into a totally different world, one where the kinds of adaptation and mitigation strategies we'll need are very different from the world today, where we have this kind of bottleneck, this kind of a choke point with large compute clusters and a handful of labs. It may mean, having better network security infrastructure, right? Maybe in the future we'll have, the telecom infrastructure that monitors for what kind of AI agents are passing through the network and things like that. But that's a far off world. Maybe, by far off I mean, 5-10 years, but it's a world where the kinds of mechanisms will not be, from on high. It will have to be more decentralized by nature because the technology will be decentralized.
Yeah, as things stand now with the compute thresholds we've mentioned, should we be worried that these will be used for, or these thresholds are some form of regulatory capture, and that they will stand as a barrier of entry to startups and trying to compete with AGI corporations?
There are potential versions of regulations that use compute thresholds as part of the regulation that could be regulatory capture. Nothing like that has happened yet. White House executive order is merely requiring disclosures. It's hard to, the classic theory of regulatory capture is you create a regulatory burden, a kind of fixed cost that everyone must comply with, but the biggest companies, because they have large legal departments, can absorb that cost better, and then it shuts out their competition. Now, in this case, the main barrier to entry is, can you afford $1 billion compute cluster and training run? And do you have, the handful of maybe a few thousand of the top ML engineers in the world? That is an inherent barrier to entry. And so the notion that a compute threshold is a kind of Trojan horse to regulatory capture seems a little farcical, and especially when you look at the actual views of the companies, right? Meta doesn't want a compute threshold. There's a lot of pushback from OpenAI and Anthropic over SB 1047 in California, which includes compute thresholds. So as a matter of fact, the companies themselves don't seem to want these. So it's hard to make that case of regulatory capture. That said, there are various forms of regulatory capture that are more plausible, right? If your model has to abide by a variety of ethical safeguards and have really strong refusal systems and so on and so forth, then that is something that Microsoft is much more capable of implementing, and closed models are much more capable of implementing. And so I would direct my ire there rather than at a mere monitoring capacity.
What we're discussing now is something that's been discussed by effective accelerationists and people who want to decelerate AI progress and so on. You write about how the supposed dichotomy between acceleration and deceleration is actually a false dichotomy. Why is that the case?
It's the case in two ways. First, on a sociological level, effective accelerationists and effective altruists it's a narcissism of small difference. 5 years ago, these are the same people. And it's a schism within a certain demographic. But they're both kind of rationalists, and they both think really hard about these issues. The true believing EACs, believe in superintelligence and think it's they just sort of want to, they have a different strategy about how to get there and how to handle it. So that's the first point. The second point is that, acceleration versus deceleration sort of imagines technology as this linear process where, there's just worse technology and better technology, and we should just be racing forward towards better technology. I think this neglects the ways in which technological development and economic development broadly is deeply path dependent. Why do we have a QWERTY keyboard rather than some other configuration of keys on our keyboard? Well, this is just a total accident of history, and there are many examples of that through technology. And so, the better mental model for technological development is more search down branching paths. There are different kinds of technology we develop. They could be developed at different rates or differential investment. And so this is where, the DACs, the defensive accelerationists, sort of come in, where they say, we are being chased by, this is the Vitalik Buterin metaphor. We're being chased by a bear, and so we have to be running forward. We can't actually just stop or pause. But there are genuinely two forks in the road. There are paths that lead to doom, and there are paths that lead to utopia, and we have to actually be very deliberate about which technologies are developed first, at which rate, how they're deployed, to make sure that we navigate down that better path.
Yeah, how urgent are these decisions? How important is the next decade, for example?
And I don't assign a high credence to this, but I think it's probably the pivotal decade. Our ability to steer technology is relatively limited, especially once it has a kind of forward momentum. And so if there is any hope of sort of picking a better path, you have to do it early. That's point number one. And then point number two is that technological discovery and innovation tends to occur in kind of punctuated equilibria, where we are sort of muddling along, we're in some kind of technological winter, and then suddenly we discover the one trick that makes it work, and there's this flurry of activity and investment, and we pick all the low-hanging fruit. And that's sort of what's happening right now. And if there are, a handful of new model architectures or new tricks or techniques that will get us to the next stage of AI, that they will probably be discovered within the next 10 years, not the next 100 years.
The AGI corporations have this goal of developing superintelligence, and sometimes they state it explicitly. Maybe talk a bit about how we should notice that this is a goal, and we should notice this is an ideological goal.
Yeah, I think I said this on the last time I was on, where the weird juxtaposition of Sam Altman testifying before Congress that they're planning to build a superintelligence and could be here within 10 years, and then Senator Blackburn from Tennessee is like, what does that mean for music royalties? And so there's this delta between the conversations. We're sort of taking the companies seriously, but not literally. And we should take them literally. I was just at a dinner hosted by Anthropic with a bunch of DC policy folks, and the representative from Anthropic was basically saying, look, how do we communicate to you guys that, we're trying to build AGI, and this is the goal. and we think we're able to do it. And, you got to take that seriously. And then the conversation veered off into, how to think about patents and copyright. So it's a challenge, and it's also sort of seeing is believing, right? And it's easy because we're sort of in this temporary lull to talk yourself into the view that things are kind of stagnating or we're hitting some kind of ceiling. And that's a kind of luxury belief that we don't have for much longer. And the ability to sort of see through that requires some kind of prior about how technology works, how machine learning works, how deep learning works, in the same way that, being concerned about climate change requires having understanding of, atmospheric physics and some kind of modeling ability to say, well, actually, a few centigrade warming on the planet could be catastrophic for all these various reasons. And so that is really the delta right now, where you have the people who are most concerned have some deep intuitions about why this technology will get there eventually and potentially quite soon. And whereas others who are maybe a little more new to the field are just looking at the latest shiny product and saying, well, this hallucinated citation. So how is AGI actually so close?
Is this a problem that will solve itself? Say we get to the next generation of models and, we have another ChatGPT moment where people become aware. If progress is fast, like we might imagine it to be, it seems to me that people will notice along the way and perhaps get more interested in the actual and deep problems of this transformation.
Yeah, I've kind of likened it to the kind of Tom Hanks got COVID moment, right? When will be the moment where, we go from saying, COVID is interesting. There's a few cases in Italy. We shouldn't really worry about it yet. And by the way, we have to reauthorize the FAA and pass the NDAA. So Congress has no space to actually deal with the pandemic, to, within a matter of weeks passing a multi-trillion-dollar relief package and shutting down the country. I don't think things will be quite that dramatic. So it will be more of a trickle, but seeing real demonstrations of agents within particular economic domains where, actual work is being performed and major automation is taking place, then it becomes a lot easier to extrapolate, to say, well, we have these agent-based systems that are, performing at human level within a particular domain. It becomes much easier to imagine why they could break out into all domains.
Makes sense. I think that if you could email an AI and get some decent work done, or FaceTime an AI, talk to a generated video, and maybe have an AI assistant or something, those are the innovations that people take note of. And those are some of the things that might change minds, I think.
I mean, human psychology is so weird, right? Like the GPT-4o with the voice capabilities, I think were an aha moment for some people, even though it's a very superficial capability, right? And we have, sound waves are, a Fourier transform. So like it should have been obvious that we could have multimodal models that can speak with annotation and sarcasm and all the things that are being demonstrated. But because it sort of cuts to things that feel deeply human, it's much more evocative than something that is just like getting a gold medal on some math test.
It matters a lot to people when when they pause in a sentence, when they stumble over their words, when they take a breath, for example. And these are small tricks that you can do when you output audio. But it matters a lot, and it matters kind of intuitively, and it matters to me too. So yeah, if we go back to talking about the ideological goal of building superintelligence, I think it seems to me that we have an alternative there, and perhaps this is something that DeepMind is doing, where they're building narrowly very smart models for protein folding, and for math proofs, and for using energy in smart ways. Is that the alternative path, you think? Is that viable? How much can we get from these narrow but very smart models?
I think we get a lot of what we want, right? We want better medicines. We want, robotics that can automate and drive productivity growth. We want personal assistance and so on and so forth. So there's a lot we can do through the application of narrow models, and we can even build narrow forms of agency. The example I think of is the AI orchestrators for Amazon warehouses that are kind of agents. They're sort of the collective swarm brain for all the robots running around the warehouse. The question is, what does superintelligence actually solve? Who is asking for this? AGI, human level, you can see lots of economic value being unlocked. Maybe superintelligence is needed to, start colonizing the galaxy. but is there a need to actually rush to that technological milestone? I think you can make an argument either way, but it's just a observation. The race to build a superintelligence is inherently an ideological goal, right? Even Sam Altman has said that he's somewhat tongue-in-cheek credited Eliezer Yudkowsky for accelerating superintelligence timelines, because he put the idea out there. He got people thinking about it. And it's all through science fiction, and you kind of gives credence to the Nick Land point, the sort of arch accelerationist, that this is hyperstition. We're building the sci-fi prophecies were kind of self-fulfilling, the idea in our brain, and now we have to go build the thing. But do we really? And we do, but do we have to do it as fast as possible? And part of the challenge here is that when you debate sort of techno-optimists, they will equivocate on what AI actually is. They'll point out that we're now able to detect breast cancer from your breath and do all these incredible things, and it does seem like pure upside. And I would agree with all that. Having a drug discovery platform that could, in a matter of minutes or days, generate novel treatments for new diseases in the same way that mRNA technology was able to get a vaccine within a weekend.
Yeah, I agree. It's fantastic, and we should have more of that.
Yeah, we should have a lot more of that. As a thought experiment, imagine these companies were saying, we're trying to build the ultimate cyber weapon, and in the meanwhile, we're also going to make a better search engine, right? And they just said that. I think people would look at it and treat it very differently. It would sound a little bit more reckless than to say, we're just trying to build superintelligence. It's like intelligence but super, or as Trump said, super duper intelligence. It sounds a little more, prosaic, but the superintelligence is a powerful cyber weapon, by definition, right? And I think this is also one of the eventualities here, is that when the national security community wakes up to this, it will become militarized. Because at the end of the day, that is the real only use case for a superintelligence above and beyond AGI or these narrow platforms.
So how inevitable is the progress towards superintelligence? When we are making general progress in hardware, general progress in algorithms, this is even beyond AI. We're just making progress in the computer industry in various domains. Are we then inevitably making progress towards superintelligence?
We're expanding the conditions of possibility, right? Within whatever compute bounds are required to build a superintelligence. If we have more compute, it becomes more feasible. It still remains, I think, an ideological quest, because obviously we can't build models for everything, right? And we've built better weather prediction models because weather forecasting is useful. We've built audio generation models because we like music. We haven't built, amazing consumer level, sonar models. I'm sure there are companies building that for enterprises and so on, but it's not a major area of private investment because we're not bats, right? We use the visual like spectrum and audio within a certain frequency range, and so the landscape of ways we can apply deep learning is vast. The notion that there's an inevitability to building a autonomous agentic system that is vastly superhuman is some kind of natural outcome or inevitable outcome, I think is question begging. I see no reason for that other than because it's become a kind of a mind virus that people are now acting on because it would seem super cool.
Should we expect the gap between open source models and proprietary models to grow over time?
That my bias is to think yes, with the proviso that smaller and open source models will still be very capable. There is a kind of trickle down phenomenon, but because of the nature of this normal nature of scaling laws, that closed models the delta between what you can do in a closed model and an open model will grow over time.
And maybe flesh that out a bit. Why is that?
Because there are many actors in the world that can do a $1 million training run. There are many, but somewhat fewer actors that can do a $50 million training run. Maybe dozens of actors that can do a $100 million training run. Very few that can do $1 billion. Fewer still that can do a $10 billion. And beyond that, we're talking about multilateral projects like CERN that require hundreds of billions of dollars in investment, where not even private companies could compete in that.
Yeah, Meta just released Llama 3.1, which is state of the art in on some benchmarks. Is that a counterexample, or does it just mean that because we are in between the release of proprietary frontier models, open source has time to catch up?
Yes, I think it's the latter, right? There's very little that goes into training these models that isn't public knowledge, that isn't published in some archive paper somewhere. And so the knowledge is out there. The main missing ingredient is access to compute, and Meta is one of the biggest, if not the biggest, owner of H100s. So they have this vast computing capacity, and really they're one of the only actors in the world that could open source a model of that scale. And partly they're doing it because their near-run incentives are, say, we're a little bit late to the game on AI. We're not an AI company, we're a social media company. And so we want to be the ones developing an open ecosystem, in part because it undercuts our competition.
Is it actually true that the knowledge of how to train these models optimally is all out there, is all published? I would expect companies in front of the AI development to not disclose anything that could give them an edge in training.
I don't work at an AI lab. I've talked to members of the technical staff, so to speak, and they're kind of restricted in what they can tell me.
But that should tell you something in itself, right? That should tell you that they probably have, or maybe they have some secrets that they can't disclose. And maybe some of those secrets are relevant to how to train models in the best possible way.
Right, but the key word there is best possible way versus a good enough way. And it seems like many of these sort of so-called bags of tricks that are being used to optimize these models on the margin are kind of trade secrets, right? It relates to the right way to tokenize the data, and maybe the training procedure, like you train on code first and how much code, and these kind of things are not explicitly written down anywhere. There's no real theory behind them. It's sort of a trial and error, and so it's more art than science in that sense, right? A lot of people say that they love Claude 3.5's sort of general personality, and there's questions about, what was the secret sauce that got them that better personality? And maybe that would be a competitive advantage that they don't want to have leak. But in terms of being able to, have GPT-4 level capabilities, most of the main benchmarks, that none of that is secret knowledge. So, and you look at the way diffusion has taken place, we're now getting open models like a 3.3, and Mistral has a new model as well that are now encroaching on GPT-4 level capabilities that are open source. But again, GPT-4 was 2022 era model. And so we're sort of in this world where we can expect to see open models come out that parallel frontier models with a 2+ year lag. But the classic example of this recent history was the famous mystery around Q-star, right? Reuters had this report saying that some whistleblowers within the company were worried about this Q-star project, and maybe this was AGI and achieved internally, and all this speculation. And it turned out that it was just an application of chain of thought prompting and reinforcement learning that was first published in 2020 in a 2022 paper, and nothing more. But that doesn't mean that it's still not a very powerful technique. And one of the ways that the knowledge is hidden is the fact that there are 500 odd papers being uploaded to the archive every month that are making various claims, and it's very hard to tell what are the ones worth pursuing, which ones are dead ends or redundant in some way. And so that's where the knowledge really is hidden. Knowledge is all out there, but it's hidden within just the vastness of all the noise around it. And so the fact that OpenAI seems to be using these chain of thought style techniques and so on is not telling us new knowledge, but it is in a sense sending a signal about what existing knowledge was actually worth prioritizing.
And maybe you're also making the point that if you have enough compute, you can kind of just steamroll all of these tricks and hacks and get to the same level of performance without perhaps having the tacit knowledge necessary to implement these new optimizations.
Yeah, precisely. I'd imagine a GPT-5 scale model will be able to emulate a Claude 3.5 without having through a few in context examples, without having to have their particular back tricks.
Meta and Mark Zuckerberg recently came out strongly in favor of open source AI. Do you think that as we scale up the models, they will become more worried, more concerned, perhaps scared about what they're releasing and maybe not release future generations?
Yeah, on a purely economic or financial basis, it's hard to imagine Meta releasing a further generation beyond the 5 billion parameter model they already have. If they go up to 4 trillion, then as a shareholder, I start to question their fiduciary duty, right? They're burning a lot of capital in doing this, and it is a kind of, they're burning a giant pile of money, right? And you can only do that for so long, just on a purely financial basis. And additionally, I think, public companies like Meta, it is not in their shareholders' interest for them to release a model that causes tons of havoc and maybe exposes them to liability and much less destroys the world. So I think there are actually quite strong inbuilt incentives, especially in a public corporation that has disclosures and a variety of other transparency duties, to being a good actor, broadly speaking. And Zuckerberg himself has said, if they developed a model that had dangerous capabilities, they wouldn't release it. This is really not the point he's making. The point he's making is these general purpose foundation models are incredibly useful. They're also easily commoditized. And so let's just commoditize the thing because it will lead to more research, more experimentation, and allow smaller actors that don't have access to large compute clusters to actually have a stake in AI.
Perhaps you could talk about how open source models can be used defensively and how it could be in the interest of the public, say, to have open source models that are below a certain capability level out there, perhaps for cyber defense.
Yeah, so you don't want to be beholden to a closed model provider if you're building AI into critical infrastructure, right? It reminds me of the brain-computer interface company that went under, and they had a number of patients that had chips in their head, and were like, well, what do I do with this chip in my head now that the company's out of business?
Did that actually happen, or is that some sci-fi story? It sounds like a sci-fi story.
That actually happened.
Okay.
I think they had some kind of long-term health insurance. But on the flip side, open source models have to be actually open source. Semantically, there's this conflation going on between open source and open weights, where Llama is an open weight model, right? The weights are public. You can go download them, but they haven't disclosed the training sets nor the exact training procedure, though their technical paper does give more detail than most. And so it's not genuinely open source, and we have to take it on faith. And it's more than faith. We know from their reputation, and we have reason to believe that they wouldn't intentionally embed a sleeper agent into Llama. But we couldn't say the same thing about a model released from China or the UAE or Russia, right? And so open models, open weights, can be incredibly valuable, but they also are a bit of a black box. And so critical infrastructure needs to both have access to open source models, open weight models, but also genuinely open source models, so that they can have the assurance that there's no sort of backdoor.
Who could release a truly open source model? What entity would have interests in doing something like that?
I mean, there are open source models, genuinely open source models that are of smaller scale, but the biggest players like Meta, they run the risk of releasing training sets and then everyone realizing, oh my God, this contains half of the New York Times and a bunch of YouTube transcripts and so on and so forth, and just opening up the can of worms of copyright and related licensing issues. So I understand why they're not doing that, and I think no company would really do that unless required by law. And you can make the case that maybe publishing the training sets that include a ton of copyrighted information is too much to ask. But maybe they should at least disclose it to some kind of intermediary that can audit it. And I think that will be increasingly important going forward, especially as these models proliferate to a variety of different modalities and domains, to have some kind of, it could be a formal regulator or a nonprofit entity, but somewhere where you can provide the training data and the training procedures in a confidential, secure way for auditing and transparency.
You worry about technological changes causing regime changes. If we look at history, if we think about the agricultural revolution, the industrial revolution, what can we learn from history about how technological change leads to regime change?
I think about this in terms of sort of the second order effects of technology. We tend to tunnel vision on the first order effects, right? The horseless carriage fallacy, that the automobile was just replacing the horse pulling the carriage. But actually what the automobile did at second order was, allow governments to project power far beyond their capitals and change the economic geography of the world. You could have longer supply chains and so on and so forth. We end up building the interstate highway system. Like all these second order implications of the automobile. And second order effects are usually driven by collective action. And so the classic book on this that I love recommending to people is Thomas Schelling's Micromotives and Macro Behavior. Great little book where Schelling introduces the concept of collective action through a story where he walked into a lecture hall one day and everyone in the lecture hall was sitting at the very back. And he surmised that, what had happened was people had an individual preference against sitting in the frontmost row, but they wanted to still sit near the front. But as each person entered the room, they each had to sit further back than the person that came before them. And this ended up being self-defeating because there still had to be a frontmost row. So there were still people sitting in the front row that just were way further back than anyone preferred. And the way you solve those kind of collective action problems, and by the way, they're pervasive, right, is through some kind of coordinating mechanism, right? So you could have had a person at the door that was instructing them, imposing a rule to say, you must fill in the seating from front to back. And that would have solved the problem, and everyone would have been better off. The reason technology drives regime change is in part because it drives the possibilities of coordination. It shifts those coordination. It renders some forms of coordination untenable and creates opportunities for new forms of coordination. And institutions have to then reemerge around those new coordinating mechanisms, right? And so a very simple example would be Uber and Lyft. The smartphone and mobile created a new possibility of coordinating riders and drivers and matching them together in a way that was a totally different way of solving the problem than traditional taxi commissions. And you could say, well, maybe the taxi commissions could have come up with ride sharing on their own, if they had enough VC capital. And maybe their local incentives weren't to do that. And so what tends to happen is the creation of these new forms of coordination don't get captured by incumbents, but instead are built up by new entrants that then drive a platform shift. And that happens both at the company level and at the level of governments and institutions.
And how do you foresee AI doing this? How does AI fit into this pattern?
Zooming out a bit, I think you can also think about this in terms of a broader digital transformation, right? So, there's skeptics of AI will often point out that, the Industrial Revolution didn't sort of happen overnight, right? There was this period in the late 1800s, early 1900s called the Long Depression, where America and most of the West was in a period of, boom and busts, credit cycles, and we're in recession for many decades. So per capita living standards weren't rising. But at the same time, there was this enormous build out going on in manufacturing, early telegraph networks, rail infrastructure. And so by the end of the Long Depression, there was this sudden sort of catch up where all of a sudden the world looked much more productive and living standards were much higher. And, someone like Larry Summers has made this point with AI to say, well, AI could happen really quickly, but we have reason to think it will be more slow because we have to build all this sort of complementary infrastructure before you get to the payoff. Now, the counter to that is that was the last 40 years, right? Tyler Cowen called this the Great Stagnation. Peter Thiel said that we had innovation in bits, but not innovation in atoms. For the last 4 years, we've been undergoing this broader digital transformation, and AI should be thought of as just a continuation of that trend, where now, we have the data infrastructure, the cloud infrastructure, the telecommunications infrastructure for an intelligence explosion to happen relatively quickly.
So maybe we should think about this as what is available to a person that is sitting in front of a computer with internet access. What has been digitized in governments, in companies, what can be accessed online, and so on. And that also tells us something about what can be accessed by AI models or AI agents, perhaps in the future.
Yes, yeah, precisely. But okay, so going back to the regime change question, if you look at the history of the United States, just because it's the history I know best, there was a major transformation in our system of government from, say, 1850 to 1950. Dramatic change, right? We went from sort of a laissez-faire economic system, sort of very agrarian, to within 100 years having, all the three-letter agencies, a NASA space program, the atomic bomb, totally different economic system. And, we did have continuity. We still had the U.S. Constitution throughout that, but there was a kind of internal regime change that took place. And how did that regime change take place? Well, in the late 1800s, the early progressive era, the rise of these, sort of Gilded Age corporations were the first examples of a kind of new management structure, right? These were the first large corporate bureaucracies, really, that that innovated and developed new science of management and understood how you could structure supervisors and managers and so on and so forth. And that learning was eventually brought into government through the influence of like industrialists like Carnegie and Rockefeller, but also just because it was in the air. And so the early administrative state, beginning with, say, Woodrow Wilson, and then, really accelerating with FDR's New Deal, was the application of this new science of management to government itself. And you saw early hints of this in the 1800s. There's some recent research showing that the expansion of the U.S. administrative state tracked the development of rail and telegraph networks because it enabled Washington, D.C. to have agents that are far away in different parts of the country and still have the capacity to monitor and solve for principal agent problems. And I think we're going to see something very similar with AI, where, say for the last 80 years, the two major power centers in the United States have been Wall Street and Texas Oil, just as a very like schematic way of thinking about it. And so we end up having either, Rex Tillerson as Secretary of State, or maybe Jamie Dimon is being floated as a potential presidential candidate, right? So our current elite in the United States is really balanced between these two major centers of gravity, the energy economy and New England. And since this digital transformation that has been going on for 40 years, there is now a new power center, a new source of wealth that's being created on the West Coast. And you see this now being reflected in politics, where, Trump has J.D. Vance as a running mate who has a lot of backing from kind of right-wing tech ecosystem in Silicon Valley. And these people have different experiences, different ideological priors, but importantly for the analogy, they have different ways of structuring organization, right? Patrick Collison and Stripe is a very different company from Visa or MasterCard, right? Or JP Morgan, right? In some ways, Collison is the JP Morgan of the internet era, right? In the same way that in some ways Elon Musk is the Henry Ford of the internet era. And they are bringing to bear the expertise they've learned and building hyperscale companies to a critique of government, right? So the example I can give here is a story. So in 2017, when Trump was just elected, the inauguration hadn't happened yet. There was a frenzy of speculation about who he would appoint to various positions because he didn't expect to win, and so he didn't really have a transition team in place. Blake Masters was running his transition part of it, and he comes from Peter Thiel's world, and so there was this early sort of signs of what it would look like to have this new tech elite have influence in government, and a name got floated for FDA commissioner, none other than Balaji Srinivasan, right? And Balaji Srinivasan, if people don't know, is this kind of eccentric, manic, paranoid personality, very libertarian. He talks a lot about crypto. He's a very polarizing figure, but his background is in computational genomics. He taught the first computational genomics course at Stanford, and he founded a DNA screening company of his brother that was the biggest in the country for a while. And so he was being floated for FDA commissioner, and I thought this was just astounding. So I tweeted this talk he gave at Startup University at YC and about Silicon Valley's ultimate exit, which was all about how the U.S. government is like IBM. It's a laggard incumbent company. It's got all this technical debt. Silicon Valley needs to build parallel systems that then will replace the U.S. government.
I think the exact question was something like, is the U.S. government the Microsoft of nations? Which is kind of ironic now, but yeah.
Yeah, exactly. Microsoft is now leading the AI revolution, is the biggest IT vendor in the U.S. government. In some ways, Microsoft is the U.S. government in terms of the rails, the bureaucracy. So all that being said, so I tweeted this link to his talk, and I described it as infamous. And then seconds later, my phone rang, and it was Balaji. I don't know how he had my number, but before I could even ask, he said, "Infamous? I think you mean famous." So I ended up offering to write a profile of him and what his plans would be for FDA. And he ended up pulling out because of disagreeing with Trump's actions on immigration policy and other things. But, in talking with him, there was at the time a variety of these articles from Vox and Recode saying that Balaji, would be a disaster because he's this naive Silicon Valley tech bro that once proposed having a Yelp for drugs. Maybe we should just legalize all drugs and have 5-star ratings for the good drug. And I thought, well, this has to be a bit of a straw man, but let's see what he really wants to do. And the plan he described to me was as follows: extrapolating from the current trend in personalized medicine and genomics, like falling cost of gene sequencing and so forth. He said that the FDA's pre-market approval regime, right, where you have to do clinical trials before the drug can be approved and put onto market, was ill-suited for an era of AI and personalized medicine. So what we needed to do instead was build a parallel system based on post-market surveillance that would use adverse effect reporting systems. So there is one of these that exists. Anytime a new drug hits the market that has some 1 in a million interaction with something, it gets reported. We can build on those systems and other big data techniques, maybe Fitbit and so forth, to correlate using Bayesian machine learning techniques the efficacy of a drug for a particular person with a particular idiosyncratic genetic profile, and then have a Bayesian prior about whether the drug is effective that updates over time. Whether this would actually work, or if you had any hope of implementing this, it is the way that we should be thinking about government going forward. What is the community notes for everything, right? What is the scalable solution that harnesses decentralized knowledge and AI local at the edge to be able to manage this transition? Because those new platforms, those new kinds of institutions will be necessary. Going back to what we were talking about earlier about what happens when you can train a powerful model that's well below a threshold where anyone can do it. You're going to need different kinds of systems. It's not going to come through a moribund bureaucracy that takes 2 years to approve a new regulatory change.
So I guess summarizing what you're saying here is that in reaction to AI, existing power structures like the US government will probably not adapt, but it will instead be replaced by new technological alternatives that will then crowd out the existing governmental structures or power structures.
Precisely. It's sometimes called the long 20th century. The core administrative law that structures how the U.S. Administrative of State works is called the Administrative Procedures Act. I think it's from 1945. Social Security numbers are from 1935. Most of the tech stack from the IRS on down was developed in the 1960s. So we're living on capital that was accumulated during the New Deal and Great Society eras, and we're sort of spending it down, right? And there are pockets of where this regime change, so to speak, is already taking place. So you take defense procurement. You have all these upstarts like Palantir or Anduril that are applying software and AI to develop new technological solutions for intercepting drones and Iron Dome like technologies or operational intelligence platforms and so on and so forth that would never have been developed by Lockheed Martin or Raytheon because of their local incentives. But historically, Raytheon, Boeing, Lockheed get all the contracts because a legacy system that is oriented around these two power networks that I discussed before. Within the Department of Defense, there's a program called the Defense Innovation Unit that is meant to be a parallel sort of fast track for these startups to actually have skin in the game and be able to win contracts. You could imagine a world where the scales start to tilt and the old procurement system shrinks in relevance and the new procurement system grows. And rarely is it the case where you just abolish something and have the new thing. It's more where you have an explosion of growth. That means the thing that is staying still shrinks in relative terms, and the new platform, the new system, the new institution grows and becomes the new norm after a transition.
Yeah, I guess a key question is whether existing power structures will let this happen. So will the US government accept being disrupted by, say, private tech companies? Do you expect the US government to allow, say, OpenAI to create superintelligence, for example? Because, we've all heard stories of government inefficiency, and perhaps it's widespread in some domains, but there are also parts of the US government that are extremely capable. So, yeah, what do you foresee here? Will the government simply let itself be replaced?
So the government is not a monolith, right? We only have a launch capacity because of SpaceX, and that was only possible because some enterprising, civil servants realized that the procurement system is broken, and that if we had these milestone payments, we could actually bootstrap our launch capacity to the private sector, right? And that learning is still taking place, but has to be extended to other areas of government as well. And there's always pushback, right? There is, in the case of SpaceX, they've been targeted by the DOJ. Elon had to pay indulgences to the Florida Save the Ocelot Foundation because apparently there's ocelots in Florida, and right, so there's this extractive ecosystem around it that is sort of nibbling at the edges. But at the end of the day, the benefit of having SpaceX is unambiguous, and everyone can see it. And so, in moments of crisis, we don't worry about this, right? And during the pandemic, for instance, the Paycheck Protection Program, which was offering forgivable loans small businesses had to close during lockdown was being channeled through the Small Business Administration, right? Relatively old, and it's an institution that normally makes loans to like gas stations and nail salons, not every small business in the country. Those payments ended up being channeled through banking system, and the SBA was sort of the wrapper around pipes that were built by the financial sector. And on the day of the program launching, the entire system crashed on the SBA side. And it was only saved because Amazon Web Services stepped in and rebuilt the portal and used their scalable cloud infrastructure to ensure that it didn't crash. So in periods where things start to break, you don't start worrying about, whose power structure is this? It's like, who can actually come fix the problem? And, maybe we move into a world of, AI agents that are transacting with each other every 100 milliseconds or something like that. And that's a world where, I don't think Bank of America is going to be managing those payment rails. Maybe it'll be done through the blockchain, or maybe it'll be done through Stripe or some other newer company that is optimized for that. But those are the kind of things that happen on their own, not because anyone planned it, not because of the outcome of an election even, but because the second order effects of the technology drive the shift in the ways we need to coordinate society.
Do you think that the US government could nationalize corporations like DeepMind, OpenAI, Anthropic, those that are in front of AI development?
We certainly could.
Yeah, the question is, how likely is it? Yeah, that's a better question.
So let me use another pandemic era example. In September of 2019, Trump signed an executive order titled something like Accelerating Vaccine Approvals for National Pandemic Preparedness, right? Very fortuitous timing, right? And this came out of a CEA report that was written by a couple professors from the University of Chicago, sort of Chicago School libertarian economics professors who had been critiquing the FDA for years and said, well, the FDA is too slow. That has all this hidden, the hidden loss of drugs that don't make it to market. And in particular, if we had a pandemic or similar emergency, we need to move really quickly. And so this executive order laid out the framework for how BARDA and the Department of Defense would work with the private sector to set up a public-private partnership in the event of a pandemic. And this ended up, like I said, great timing, because this was the framework that was used for Operation Warp Speed. In Operation Warp Speed, while we didn't nationalize Pfizer, we didn't nationalize Moderna, we did have a former board member of Moderna running Operation Warp Speed. And we did have enormous advanced market commitments that pulled forward the vaccine in months. And so my anticipation is that this isn't the 1950s, it's not the 1940s anymore. We very rarely do we nationalize companies outright. Instead, we have quasi-nationalization for national champions via these public-private partnerships, via contracts, and via the revolving door of who sits atop the governance of these organizations.
So there's the question of how likely it is that you get like pseudo nationalization going on, but there's also how risky it is. If the US government were to nationalize and perhaps combine companies in front of AI development, at the frontier of AI development, that would result in an enormous concentration of power. I do worry about this, and I do worry about how such an entity would act in relation to other countries, in relation to, say, other private companies. Are there any lessons from history there? I'm thinking specifically of, say, the end of the Second World War or the collapse of the Soviet Union, where we have the US at the kind of height of its relative power. What can we learn about the US, how the US would act if it had enormous power?
I mean, the US has had enormous power, right? We've been effectively the global hegemon since the end of the Second World War. So, and, we've made mistakes, but I think even, critics of US imperialism and so on would say that, relatively speaking, we've been benevolent. We've had foreign excursions that were probably hubristic and we flew too close to the sun, but we haven't been out there trying to dominate other countries. And to the extent that we have, interfered with other countries, it's pursuant towards them liberalizing or democratizing. And so I don't think that basic cultural foundation of U.S. power will change. So the question then becomes, what are our options? Are our options to have this enormous power being concentrated within private hands, or to have some public and democratic involvement? And I think the latter, to me, is potentially the better scenario, in part because Silicon Valley in particular has a very, it was founded by a bunch of congregationalists who didn't like hierarchy, and it's there's a lot of sovereign citizens in Silicon Valley. Let's put it that way. People who think the law doesn't apply to them, and some of these people may be leading a few important companies, right? And if they get delusions of grandeur or messiah complex, they may say, well, take this AI model from my cold dead hands and abscond on a private jet to El Salvador. So you can't necessarily rule that out. Let's say that. And so, having, especially early on, some basic involvement from the national security apparatus, I think is actually valuable. I think there are people who worry that this will bias the development of AI towards militarization.
That would be my main worry, that a sort of pseudo-nationalization would lead to AI being developed mostly for military use, and AI being used to compete with China for kind of global dominance in a way that would be perhaps very risky for the world.
And I can totally see that. I'd just ask, what are the counterfactuals? Is this priced in? Is that going to happen anyway? The Department of Defense has $1 billion budget for directed energy weapons annually. I haven't seen these weapons. I don't know if we're using them. It's a lot of money to be spending on microwaves.
Directed energy weapons, is that a smart way of saying lasers, or am I misunderstanding something?
More like a very focused microwave beam or neutrino beam. There's different versions of it. Then this sparks conspiracy theories about Havana syndrome, and maybe we're like shooting neutrinos to the Earth so we can give people a headache on the other side of the planet. I don't think we're doing any of that stuff. But the point being, it's a very speculative technology that you could make the case is an example of Pentagon waste, and yet we're willing to expend $1 billion a year this sort of vaporware. And so I would imagine we're also willing. The U.S. military is willing to spend $1 billion a year on something that actually is useful. And the $100 billion training run will probably first be done by a government, or with government involvement, or advanced market commitments of some form, different public-private partnerships. And so I tend to think that some kind of joint venture, some kind of close arm's length collaboration between the private sector and government is inevitable. It's already happening piecemeal. OpenAI has a partnership with Los Alamos, right? That the same Los Alamos that we know from history, to red team their models for, I think, biological and radiological risks. Anthropic is deepening its partnerships with the national security community for preparedness and defensive technology and cyber preparedness in particular. And I think it's actually part of their corporate duty, right, and civic duty, really, to share their insights with the U.S. government. And the U.S. government cannot simply have a secret AGI project that no one notices, in part because we would see the gigafactory, with satellite imagery, and also because all the talent is in these labs. So I'm not worried about there being a crowding out where these private companies get co-opted and all their energy is going towards building the AI Stuxnet that is going to be used to counter China. Rather, I think they're going to continue building what they're building, and as those capabilities cross dual use kinds of capabilities and thresholds, the U.S. government will learn about what's possible, what's newly possible, probably inevitably apply those techniques to the NSA and other agencies towards cyber defenses and cyber offenses. And whether that's good or bad, we can't really stop it.
Do you think AI involvement, say U.S. government involvement specifically in Anthropic and OpenAI and DeepMind, does that accelerate AI progress or decelerate it? Or perhaps tell me about how that's, as we discussed, a false dichotomy. But yeah, how does it affect the progress of specifically kind of frontier AI?
It may slow down on the margin, right? So I think the more important implication is it enables the kind of learning by doing within government, right? So we now have the AI Safety Institute at NIST, and there's a similar organization in the UK. And these are government bodies or quasi-government bodies that are for the first time having to, develop evaluations for models, safety evaluations, safety benchmarks. And they've never done it before. And there's really no one in the world who's done it before. We've done it maybe in the last few years. There's people who have developed this expertise. And so they need to have, some training wheels, right? They need to have some practice to develop the muscle and organizational capital to do this when it matters. And so it's important to start doing it now. And that will necessarily involve aspects of the security state, because if we want to red team a model for its knowledge of how to build a cyber weapon, the secrets of how to build a cyber weapon are secret. So we need people who know those secrets to test the model, right? And this is an important precursor, because if we do need to intervene, we need that muscle already in place, and we need some like more objective criteria of what dual use even means. And that will only come through these kind of partnerships. And so, building these triggers. And the other thing I think about is dual use has a very particular meaning in the U.S. context, where under export administration regulations and ITAR, which governs international, weapons of mass destruction and other dual use technologies. If OpenAI or Anthropic or any of these labs were ever declared dual use, they would have to lay off half of their employee base, because under U.S. law, companies can only build dual use technologies with U.S. persons. Right. This is why SpaceX can't hire non-Americans, and this could be a major inhibitor to ever making the determination that a technology is dual use. Right, because the moment you do that, not only does the whole sector, hit a wall because all their Polish engineers have to go back to Poland, but also it's counterproductive, because suddenly all those internal secrets are being cast to the wind, and all the people go back home and share the secrets with their co-citizens. And so we need to be thinking ahead to not only how to define the triggers for dual use, but by thinking about what is the right framework for what dual use implies in the context of AI. There could be techniques that are being learned at Suno, the music company, that make their models much more sample efficient, and those techniques could be equally applicable to a biological platform. And so there's not really there's a huge substitutability between these different AI platforms in terms of the technical knowledge that they're acquiring. And so we shouldn't restrict advanced AI development to U.S. persons. We need some other framework for that, and having that framework in place needs the planning for that needs to happen now. And because it's going to be multilateral, there'll have to be a major diplomatic effort from the State Department to define, maybe some like AI talent network where, allied countries and democracies get to work on advanced AI systems, even if they're dual use in nature.
Let's talk about the economics of AI. You have a post where you push back a little bit on kind of the notion of an intelligence explosion, but you also note in that post that you are perhaps relative to the, say, average economist, you're more convinced that something akin to an intelligence explosion is possible. Maybe just to sketch out how would you model such an explosion? What would it mean for the economy to move from 3% growth rates to 30% growth rates, for example?
Yeah, so people mean different things by intelligence explosion. I think the standard meaning people use is you cross some threshold of like the AI researcher that then can build its successor ad infinitum. You have like this bootstrapping towards superintelligence. I'm a bit skeptical of that, in part because I think one of the big lessons from deep learning is that there is these systems are powerful insofar as they are very highly dimensional, have a lot of dimensions, right? Tens of thousands of different dimensions, and there's limits to how you can compress those dimensions into something smaller. A kind of irreducibility to the vector space, right? And so going from merely human level to vastly superhuman isn't just a matter of figuring out better algorithms, right? Or somehow introspecting on your model weights and finding a better configuration of weights. Chances are those model weights are probably in some kind of local optima to begin with, and so scale will still be a factor. You can't, and so even if there is sort of in the bounds of compute a process where we cross some threshold and then the models get much smarter within those bounds, they will still be bounded, right? And we will still be rate limited in the intelligence explosion by the availability of compute and other bottlenecks like energy and power grid and so forth. So that's point number one. When it comes to the economic implications, so there are worlds where one of the ways where AI could drive stupendous growth in the near term is through services, right? And the U.S. economy is about 70% services. Most modern economies are service dominated. The services are labor intensive. They are often non-tradable, right? And non-tradable goods don't have a law of one price, right? Because you need to be in person to experience them. And so, one of the reasons we've had relative stagnation for the last, say, 30 or 40 years is because the economy is services dominated and services are resistant to productivity improvements. But because that's 70% of the economy, if you get major productivity accelerations in services that could lead to a much higher rate of growth, precisely because it's been the kind of stagnant part of the economy for so long.
That makes sense to me. Maybe for the non-economists listening, talk about the difficulty just of maintaining 3% growth rates and what it would mean to enter a regime of 30% growth rates. How insane that would be.
Yeah, merely maintaining the 1% to 2% growth that we've had as a frontier economy for to the end of the century implies enormous changes, transformational change to how the economy is structured. I think if you just extrapolate, say, 1% or 2% growth out to the end of the century, then U.S. per capita GDP is in the six figures, right? And so thinking about the median person having a Bentley or something like that, and the resource utilization implied by that is also huge. And so something's got to give, right? And if there is a major sort of step function increase in growth on top of that, I don't think that means we have like 30% growth indefinitely. It merely means that we have a sort of sigmoidal spurt of growth that lets us catch up to the new steady state in a rapid period of time. And that could be, very, very dramatic. You'd almost rather smooth a 30% growth phase out over, 10% growth over 3 years rather than 30% growth over 1 year, because of the scale of the disruption. But I don't think we just maintain 30% indefinitely. And the models that suggest that are all models where humans exit the picture, right? They're models where AI engineers and researchers are just generating inputs that go into better AI engineers and researchers. And at the end of the day, like, the economy is for people, and we're consumers, and what gets built in the economy is downstream of consumer demand. And you can't just have more production without more consumption. And so growth, like really, really explosive growth, is inherently bottlenecked by our ability to consume. This doesn't enter the equation of some of these models where basically labor share of income goes to zero. And yes, you can have hyperbolic growth, but then we're just, it's an economy of AIs building things for AIs.
Yeah, but are there limits to how much we can consume? You could imagine under, say, we have an aligned superintelligence that just presents all of us with the lifestyle of a present-day billionaire. I think people would still be interested, like perhaps today's billionaires are, in increasing their living standards, obtaining something more, something different. You have a post again that I've read where you discuss the boundedness of the subjectivity of value. What are those bounds? What are the limits to how much we can consume?
Right. I mean, there are intrinsic limits because there's a certain bit rate of that passes through our eyes, ears, and mouth and nerves, right? And so in a literal sense, we can only consume so much media. We can only eat Michelin-star restaurants, every day for eternity, right? And and so at some level, there are inherent limits to growth just in terms of human utility, right? There's a kind of saying in economics that wants are infinite. That's only kind of true, right? They are potentially infinitely, insofar as we care about relative status, like maybe we can enter into an infinite loop where we're always just trying to one up each other. But especially when you get into worlds where we could simulate or emulate a mind in a virtual environment, then GDP becomes basically irrelevant, right? Because I could, virtualize, simulate my 72 virgins and a Lamborghini and whatever people want, right? You live in heaven at that point with for the cost of 6 kilowatt hours, whatever the electricity rate is, right? The subjectivity of value kind of ends up breaking down in more sci-fi AI scenarios because we're so used to being within this regime where GDP growth means incremental productivity improvements where we have a better mousetrap.
Great. So we talked about the consumption side of the economy, but there's also the production side. And there you've written something that's somewhat skeptical about humans kind of exiting the economy, no one having jobs. You write, technological employment is only possible if capitalism collapses. Maybe you could explain that.
Yeah, this goes back to what I was saying about the consumption constraints on production. So, a stylized fact of advanced economies is that over time, the labor-intensive part of the economy becomes a bigger and bigger share of the economy. Right? This is known as Baumol's cost disease. You have rapid productivity growth in manufacturing, manufacturing, but you still need teachers, you still need nurses, you still need childcare workers. And so their wages have to rise in proportion with other sectors of the economy to retain that workforce. And over time, the most productive parts of the economy are super deflationary, price of things goes zero, and everyone is a nurse or a teacher or the things that remain resistant to automation. Now, that doesn't change in an AI, post-AGI world, in part because we're still the ultimate consumers. Everything that's being produced is being consumed and is being produced for humans. And humans need some income to be able to afford that production.
And that couldn't just be some form of universal basic income or another form of transfer.
It could be, but I don't think you might need that to provide some kind of floor or basic standard of living. But the economy itself, the circular flow of demand within the economy will drive in general equilibrium incomes to rise, right? And maybe that means we're all pet therapists or something like that, or whatever the new service sector jobs of the future will be. But we're still going to be earning income and consuming the fruits of AI labor.
When I interview economists, this is often a point they make, that new jobs will arise to replace the jobs that are now being done by AI, like we saw in the transition from, say, agriculture to factories and then to offices. I often wonder whether there could be a failure of imagination on both sides here. There could be a failure to imagine these weird jobs that might exist in the future, like pet therapists. But there could also be a failure to imagine that things might be different because AI is different from other technological transitions. It's which jobs could be available. I mean, pet therapist is kind of semi-serious, I guess, but we can't all be pet therapists, right? Which jobs do you imagine being available when we have, say very advanced AI?
Yeah, I just saw on TikTok yesterday a professional back scratcher, woman with long acrylic nails who will gently caress your back for probably $100 an hour or something. And then I also get TikToks of like the $1 head massage you can get in India, where the guy just slaps your head a bunch. It's hard to predict what these jobs will be, and we talked about this a little bit in the past about the kinds of sources of intrinsic scarcity, right? And those include positional goods. They also include rents, right? Rent seeking. I work in the nonprofit sector. And I think my job, I have a modicum greater job security than my colleagues in the private sector, because if their job can be automated, it will. Whereas my job depends on the good graces of large foundations and philanthropists. and what they're paying for is not necessarily my written output, because maybe I could get ChatGPT to write my white papers for me. What they're paying for is in part the combination of my ideas with my personal relationships. Right. The fact that, in my case, I work with members of Congress and staff on Capitol Hill, and there's a legal structure that will require that we still have members of Congress making important policy decisions. And whether you have access to those members of Congress does not necessarily depend on you writing the most persuasive essay, but whether you have a trusted relationship with them. And maybe that trust will become more important in the future because of the growing illegibility of society and not knowing what to believe.
This is extrapolating into perhaps the shorter medium term. I'm interested in kind of the end state scenario where you have AI capable of doing, say, interacting with the legal system or the government, or perhaps AI is the government. In the limit, what jobs could humans do?
So when I look around the world at what countries or regimes most closely approximate a post-scarcity society today, I think of the Gulf states, right? And these are, Saudi Arabia has a giant spigot that can turn on and off. Oil comes out, and then they can build mega projects in the desert, right? But as a consequence of that, this is, used to be known as Dutch disease, the classic resource curse, is that countries that have phenomenal resource wealth, like Norway or Saudi Arabia, often have very dysfunctional politics, because the economy is not built on the basis of human capital or productivity growth or labor productivity. It's based on who do you know, are you a member of the royal family, so on down the line. And so there ends up being battles over rents, and that leads to very corrupt polities. And the countries when we look at the countries that exist today that are relatively stable, like Saudi Arabia, is because they've overcome that rent-seeking problem through the consolidation of power in a royal family and an autarky. Norway is a bit different. Norway has a sovereign wealth fund that is managed by professional fund managers, and everyone lives a very high standard of living, and even their prisons are nice, right? And so a future world where we do have explosive growth and there is a kind of post-scarcity economy is one where the remaining, where everything kind of becomes a rent, and the worlds where we do have technological unemployment are, like I said, worlds where basic market capitalism kind of breaks down, and we move to, there's different versions of this. You can imagine moving back to a more forager style lifestyle, where sort of high tech hunter-gatherer societies where everything can be produced locally because of localization and the fact that we have factories in our backyard and fusion powering it and so on. But no one needs to really work but for making each other nice necklaces and dream catchers that we barter over, kind of gift economy. And then there will be other polities that go the more Gulf state route, where they restore they counter the forces of rent seeking and the corruption that brings through power consolidation and the imposition of a strict moral code that regulates, among other things, whether you can have your jailbroken phone in public and stuff like that. Those are all plausible to me. I think the reason economists have trouble intuiting these scenarios is because they're imagining that market capitalism continues on in more or less a normal form. And so the worlds where technological employment is realistic are also worlds where capitalism kind of fails and is replaced by something different. And it's not free market capitalism plus a UBI. It is some new form of economic social organization.
Let's talk about differences between AI cognition and human cognition. This is perhaps relevant to the question of whether AIs can replace humans fully or automate everything that humans do. So just in a general sense, how similar is AI cognition to human cognition?
So I think it's similar in kind, even if it's different in specifics. And I think a useful example of this comes from a project at New York University, where a team of researchers were wondering, what would happen if we just attached a GoPro to a baby's head and recorded everything it saw as it crawled around. And this was partly to explore, what is the sort of sample efficiency of these models for learning language, right? Because one of the critiques of large language models is they're trained on trillions of tokens. They've read every book ever produced, and they're just now sort of at maybe a graduate level of reading comprehension. Whereas humans, we go, yes, we take 16 years to get to that level, not 3 months in a supercomputer, but we see many fewer examples, and yet we're able to learn language. And so this team at New York University, they put this GoPro on the kid's head and discovered that using a very simple language architecture, that from just the vocalizations of the parents in the room and everything the baby was hearing around it, they were able to begin piecing together basic syntax and semantics within this AI model. Now, the baby also has multiple advantages. We are innately wired to acquire language, right? We probably have a number of inbuilt priors that make it so we can leap forward in the gradient descent and get to language fluency faster than purely brute force mechanism. But those inductive priors are Kant's a priori or evolutionary a posteriori, right? All the a priori knowledge we have encoded in our brain were post hoc knowledge acquired by evolution through natural selection. And most of that is not hard-coded in our DNA, right? Our DNA, human DNA, maybe has 20,000 base pairs that code for proteins. There are a number of other parts of the DNA that code for epigenetic functions and protein functions, but then the rest is kind of junk. And so, you can't really encode a blueprint for a human body within 20,000 genes. What instead biology seems to do is harness gradient descent and the fact that balls like to roll down hills to set up the hyperparameters and the reward signals that then guide human development from embryo on up through processes that closely resemble gradient descent with the right hyperparameters. And you also see this in the evolutionary literature where, in many ways, a cow and a giraffe are the same animal, just the giraffe has a longer neck, right? And so mammalian DNA encodes for a basic body map and then has kind of attributes that can be molded. And this actually this, in a sense, smooths this morphology, consistency of morphology smooths the lost landscape for evolution to operate over. Because if natural selection were just purely blind, we would never have evolved because the lost landscape is so jagged. And so, we sort of evolve the ability to evolve, right? We have Darwinian mechanisms that then select for sort of, kind of meta learning within a genome.
But I think efforts to guide machine learning in this way, or build in some hard-coded kind of heuristics, those have often been outcompeted by simply making the model bigger or training on more compute. This is Richard Sutton's bitter lesson. So I think maybe the interesting question here is, what can we learn from how humans learn, and can we use that to improve AI? Can we make AIs more sample efficient so that they could learn from, say, what's available to a baby instead of thousands of years of examples?
I would just dispute the premise a little bit. So, there's a version of the bitter lesson that says, scale is all you need, and you shouldn't hard code in any priors, and that is true for certain kinds of priors. Like if you hard code in, like the way a spider has an innate knowledge of how to make a web, there's actually very few examples in evolution where you have that degree of hard coding. What you instead have are architectural features that imply a certain prior, right? So, equivariance or permutation invariance in the case of transformers, right? Transformer architectures have a permutation invariance where that builds in a kind of prior into how it processes tokens and sequences. Image models that build in a kind of equivariance so that an image that is flipped or just transposed to the left or the right doesn't get treated as a totally different image, but as the same image. Those kind of priors, if you want to use that word, are core to sample efficiency, right? It's why these models can learn quicker if an image model can say that this is the same face, just moved over a few pixels. It doesn't have to learn the face a second time. And my intuition is that those are the kinds of priors that matter most to sample efficiency, and they're not mutually exclusive with believing the bitter lesson, right? The bitter lesson just says with those priors in place, and then scale and search is the thing that matters.
Another difference between AIs and humans is that humans are just, for now, much better in highly varied physical domains. Humans still outperform robots. Do you expect that to continue? Do you think that we can learn how to do robotics? Is robotics mostly a software or a hardware problem?
Yeah, when we last spoke, which I think was in the fall of last year, I said that I expected to see rapid progress in general purpose robotic foundation models. And I think we have seen that, right? We've seen companies like Figure One or Tesla's humanoid robot make really rapid progress to the point where I can remember a year or two ago talking to a machine learning researcher, science policy guy, who was like, well, I'll believe it when AI can fold laundry, because there's been competitions going back decades now where engineers submit, RL trained systems that can barely fold a t-shirt. And, now we have robots within the span of a year that can, not only fold a t-shirt, but can fry an egg and collect and fold all your laundry, go park a car potentially, right? And now they have like touch sensors, right? So the Tesla's humanoid robot can actually adjust the pressure sensitivity of its hand when it's picking up an egg versus picking up a more solid object. And there has been some neuroscience research suggesting that if transformers are similar to anything that goes on in the brain, they're most similar to motor cortex and the cerebellum, where there is evidence that cerebellum has like a residual stream and it's sort of sequence by sequence. And so it may turn out to be the case that transformer architectures are actually better suited to motor control than even language. And we certainly see early signs of that, where also these general purpose foundation models are able to learn via demonstrations. You may have seen the demos where the robot watches somebody playing drums and then it goes and picks up the sticks and plays the exact same drum line. So I think progress in robotics is going to will parallel progress in other areas. If it's slower, it's because we're using mechanical actuators and we don't have the half a billion years of evolution that optimized for the very metabolically efficient biological organisms that require very little energy, that repair themselves if they get cut or injured, right? this is a level of competence that is hard to imbue into things made of metal and wires and transistors.
Do you think robots will be limited, like self-driving cars, by their mishandling of edge cases or by their lack of reliability, lack of very strong reliability? I think it would be difficult to convince people to let, say, a robot fold their laundry in their house if that robot was not extremely reliable, if it's walking around among people. Yeah, do you foresee that as a problem for widespread robotics?
Not necessarily. It depends on the use case, right? So maybe you need a high level of reliability if it's in a nursing home or a hospital ward. But this, we already have Roombas, right? So provided the amount of damage the system can do by getting the edge case wrong is limited, I think the adoption will be quite quick. And in the case of a Roomba, if it tries to vacuum up some dog poo, it could ruin your carpet, right? And so there are edge cases even there, but still people will adopt it. And these humanoid robots are going to have hard inbuilt rate limits where they're stuck at walking 3 miles an hour. They're never going to become like iRobot and start chasing you down the hall. But maybe they could if there was like software vulnerability and someone did an over-the-air exploit, right? And so that becomes an issue. But this is why hardware security becomes that much more important.
Another difference between AIs and humans is AIs are much more knowledgeable than humans in a certain sense. They are knowledgeable across a very wide range of domains. What should we make of AI nailing a bunch of, say, high school tests and college tests and perhaps the LSAT and so on, tests that require knowledge to be retrieved and presented in certain ways?
Yeah, so there's one view that argues that the success of large language models on, say, the bar test or LSAT or whatever is a bit of a illusion of intelligence, because rather than learning general principles, these models are developing kind of complex inductive biases that let them copy and paste from patterns that they've seen before. And there's a lot of truth to that. But it's also the case that if you ask a cognitive psychologist, that human reason works similarly. We don't sit down like we're Bertrand Russell or some logical positivist and think in terms of the logical atomic structure of thought. We apply various reasoning heuristics that copy and paste from similar structures that we've seen before and build up from that, and then formalize it with the help of language, because language lets us externalize our thought into the environment. And so you've seen this already, where like there's people who complain that if you ask a large language model to count the number of words that are in this sentence or count the number of letters that are in this prompt, that it will get it wrong. But if you give it a chain of thought example of how to do that, where you first take the sentence, break it down and enumerate each letter, that the model will just do it, right? He'll do it right away. And that's an example of applying a kind of pattern and reapplying it. But it also shows that these models, which we think are limited in a certain way, actually aren't, if we give them a little bit of a nudge in that direction. So, I do take the critique from folks like the creators of the ARC context, where LLMs struggle to solve basic sort of spatial reasoning problems that they haven't seen before because it's not in their training set. Totally true. But I think the way to think about this is, if the tokens that the AI is seeing are like its input, its sensory input, the data that we receive as humans is highly multimodal, right? Every photon that hits our eye is like a token. These models, they maybe have 50,000 tokens, so they're like, of course they can't interpret a visual image where they've been really trained on sub parts of words. Right? They are from that perspective like Helen Keller. They are blind to those kind of sensory inputs, and maybe better tokenization would help that. But also multimodality and transfer learning through a large number of modalities could end up leading towards better performance on such tests. I think it remains to be seen, but I wouldn't count out that these existing approaches could eventually, pass the ARC challenge with flying colors, and also be able to like dynamically adapt every edge case in a self-driving car or things of that nature. There could still be new tipping points that we've yet to cross. In part because, when you look at like Epoch AI's projections of compute scaling, we're 2030 is like the crossover for like a brain-sized model. So the models we're using today are still very, very small in a certain sense.
Which is a weird fact, given when you look at what current models can do, they seem to be approaching human level in some domain, at least, writing a high school essay, for example. But yeah, they are, when I'm interacting with models, I'm constantly kind of disappointed that they can't, push for something truly creative or create something kind of at the edge of human abilities. And of course they can't, right? Because we're not there yet. But that's just been my experience. I think one question is, what should we make of the fact that AIs work incredibly quickly? They can output something very fast. They can output like a pretty good high school essay very quickly and a pretty bad scientific paper just as quickly. In which domains does it matter that you're very fast and that you output very quickly?
I think it matters really in almost every domain, right? Because there is this trade-off that's been discovered where multi-agent architectures that are able to, with very fast inference, generate, thousands of outputs and then have some selection process to pick the best outputs and then iterate on that can actually compensate for scale, right? It can trade off at scale, and you can approximate what it would be like to have a 10x bigger model with a smaller model, but with many agents operating in some kind of team. And that the applicability of that will, pay dividends to anywhere where AI is applicable. Beyond that, I think there's a sort of sense in which, we're kind of biased by, the temporal and spatial scale that our mind works at, right? Joscha Bach has speculated that maybe, plant systems have some kind of low-level agency that we just can't really detect because they move at such different time scales. But if you run a time lapse of a plant, you can see the plant sort of reaching towards the sun and so on and so forth. And because they don't have a central nervous system, they communicate sort of cell to cell, and that moves at the speed of sound rather than the speed of light. And so, maybe there is some kind of information highway, some kind of forest internet that the trees are communicating where the water's coming from and so forth. And maybe, so this is another dimension of AI risk, where merely having systems that are human level, but could operate at blazing fast speeds, from the perspective of those AIs, if those AIs have some kind of inner experience, they will be looking out at the world and seeing humans as if they are slow moving trees and plants.
Yeah, which would be an enormous advantage if there's a competition for power in the world. Just speed alone. You could imagine me having, say, 10 years to form my next sentence as opposed to having to do it on the fly when talking to you. And, the speed becomes its own capability if you can react quickly enough.
Yeah, absolutely. This is why there have been proposals. Yeah, I think Jan Tallinn has suggested this, maybe Max Tegmark as well, to have some kind of speed limit in these systems. And probably not a bad idea, but also hard to imagine how that gets enforced.
Let's talk about AI and religion. How do you think AI, specifically quite advanced AI, could affect religion?
There will be different reactions depending on sort of where you exist within sort of the esoteric versus exoteric span of knowledge, right?
You got to explain that one, I think.
So, what does the person on the street experience versus the rationalist sitting in their cave who has thought about all these problems and can sort of see through the miasma of deepfakes and so on? I think back to a journal entry Kierkegaard wrote when the Mormons visited Denmark in the 1850s. And Kierkegaard noted that he thought that their theology was, I think he described it as a retrograde step in theology from the spiritual to the concrete. Because historically, the trend in theology has been for God or concept of God to become more and more abstract, right? The world becomes more disenchanted and God becomes like this abstract being. Whereas the Mormons told Kierkegaard that God wasn't everywhere, that he wasn't omnipresent, but rather moved with great rapidity from star to star. And Kierkegaard surmised that this was probably due to the influence of the telegraph and early rail network. And so there's a sense in which Mormon theology, because it was emerged during the Industrial Revolution, had a much more materialistic conception of God that saw God as not separate from the world, but bound by the same laws of special relativity and so on that everyone is. And so I think AI also has the potential to influence conceptions of what AI is. At first order, it makes, this goes to, the title of the Ray Kurzweil book, The Age of Spiritual Machines, right? We sort of have a sense in which what a spirit is somewhat demystified, right? A spirit is a operating system. Spirit is software. Spirit is a law, right? Software is a law-like property where the same software, the same logic gates work here as they would in Andromeda, right? But regardless of the substrate. So Yosher Bach has talked about this as leading towards a kind of cyber animism, that we begin seeing spirit as something that is actually normal to talk about. At our scale, spirits exist, right? And going back to the discussion about forests and plants, whether they have some kind of agency. Yeah, they used to believe, and the Shintos in Japan still believe that forests are filled with fairies and have a kind of agency of their own. And maybe something like that was actually kind of true, right? Maybe we went too far in sort of the post-Protestant Reformation of sort of disenchanting the world and pushing spirit into something super abstract. And maybe this is also why we have the hard problem of consciousness and challenges conceptualizing what it means to have spirit and matter coexist.
Do you think we could really be drawn to these spirits, say, if we understand that the spirits are actually, say, just models running on our phones or models running in trees, or we've embedded models everywhere in the world? Does it seem magical if it's fully understood? I think it is the main question.
There's a difference between intellectual understanding and kind of visceral grokking that I think what separates magic from not magic, right? If a magician reveals how he does his trick, and actually it's like the super simple thing that just some misdirection fooled you, it's like very disappointing, right? It's disillusioning. But you can study the foundations of deep learning and theoretical deep learning all day long and still feel kind of spark or some kind of magic when you interact with advanced AI systems, because it's a very high dimensional thing that is beyond our capacities to grasp, and is inherently that as such, right? Because we are computationally bounded, and so anything that exceeds our computational bounds is strictly uninterpretable to us, not cognizable to us. And the way these models get integrated into the world is going to be, there will both be the very big models that you go talk to like oracles, but then it'll also suffuse society, right? We already have algorithms that, if you ever scroll on TikTok or Instagram and suddenly you're being shown things that were on your mind, but you never articulated. It's like, how did it know that? Well, there's probably all kinds of ambient cues that are being put off, and the machine learning algorithm running the recommendation feed has picked up on those cues. They're not made explicit, but the world becomes much more agentic.
There's a common claim that people believe their phones are listening to them. And I don't think phones are actually listening and recording conversations and using that to serve up ads. It's just that these recommendation systems are so good that it seems like phones are listening.
Yeah, and you're mostly blind to all the signals you put off. This is why cold reading works, right? Mentalists can somehow know that your grandmother had buried a locket in the backyard. And it's like, how did you know that? Well, you probably gave a lot of hints that you didn't even realize. The corollary of this is that we're all becoming a bit more schizophrenic. For the most part, there are no conspiracies in the world. There's no lizard people sitting somewhere in the World Economic Forum that are like coordinating the world. But there will be as if agencies, sort of meta agents, and there already are. Corporations, cultures, nation states are already kind of meta agents. There will be more of those meta agents. And we will move into a world that is much more, in a sense, polytheistic. Joe Henrich's work on the rise of what he calls big gods sort of illustrates this point. So prior to the start of history, right, with early civilization, Sumeria, and so on, religion was mostly animistic, right? Hunter-gatherer society sort of saw this sort of unity between the spiritual and the concrete, the symbolic and the natural. You could do a dance to bring on the rain, and so on. And it's only with the earliest city-states and then the nation-states where gods take on the identity of a people, right? And at first, there are multiple of these gods, like a whole pantheon of them, where there's the god of Sumer and the god of the Assyrians and the Canaanites and the Judean god. And over time, as nation-states consolidate, we get the first monotheistic religions. And these are the big gods. And you can sort of think of these gods as representing the meta agent of that nation, right? The cybernetic system that gives rise to an agency that's more than the sum of its parts. And that's an incredibly useful social technology, right? Because it can help align a people to, collective action. And, over time, as governments have gotten stronger and we've had, the scientific enlightenment, we sort of pushed our notion of God even further into the periphery, where, maybe God is now just like some abstract concept of humanity or something like that. But I think this could end up running in reverse, where the fracturing of society that could occur under an intelligence explosion, where existing nation states start to fragment and, more localized forms of production become possible. Once again, you think about the town local schoolhouse, that got displaced by the large consolidated school district because of labor costs. And, now we have AI tutors. Maybe we could reconsolidate and go back to more communitarian modes of living. But by the same token, there will be a proliferation of these meta agents and thus a proliferation of things that we could speak of as kind of demigods. And this is a much more polytheistic equilibrium than our current one, and goes to, I think, a through line through a lot of my thinking on this, that, inspired by Robin Hanson, that there's these kind of two modes of morality, the kind of forager morality and the agricultural society morality. And we are agricultural society peoples. Like all our myths go back to the Garden of Eden, which is really an early agricultural society myth. This could, but the forager style of thinking is actually much more natural to us, which is, also the reason why, Freud wrote Civilization's Discontents, because civilization is a very unnatural thing. And we long to be part of more communal social organizations. That could end up being a kind of path of least resistance, therefore, because this is the way we prefer to live. It just hasn't been possible in modern society because of the economies of scale that are offered by large nation states and cultures.
Do you think AIs will become conscious? Do you think current AIs are already conscious?
I think the question is harder than a lot of people give you credit, right? We don't have a final theory of consciousness to begin with, so it's hard to say that a large transformer model is incapable of consciousness. I don't know how anyone has the grounds to say that. That said, I don't view consciousness as some kind of like primitive, right? Like some kind of like panpsychists believe that everything is a little bit conscious. It's conscious, nor is consciousness just a product of like a lot of information processing. Just integrated information theory would have it. Consciousness seems very specific and very functional, right? We are mostly unconscious. We are 99% philosophical zombies for almost everything that we do, and the conscious experience we do have is very limited in some ways. Our brain tricks us into thinking we're more conscious than we really are. But then you introspect and think about, what are we conscious of? And we tend to be conscious of things that surprise us, new things that enter the scene. When we're in the process of learning a new skill, we're hyper conscious. Practicing something that we're already adept at, like driving a car, we can go on autopilot and sort of steer and drive and get to our destination with barely paying attention. And so consciousness, in terms of the sensational experience and inner theater that we sense that we have, seems deeply related to learning and our ability to form coherent models of the world.
I guess the question there is often for any function you can name or any evolutionary pressure that could have resulted in consciousness, you could always imagine some agent that can do that thing without being conscious.
But this goes to the point about sort of us being mostly unconscious, right? We are mostly, when we're driving a car, if we're an experienced driver, we are driving it unconsciously. And so consciousness only enters the equation if we need to learn new things. So consciousness seems very deeply interconnected with both online learning, our ability to learn in real time, and how we allocate attention, as well as coherence. You cannot be conscious of something incoherent. Our mind strives to make the things that we perceive in some ways coherent. If it fails, then you just see noise, right? And I'm really just recapitulating Yosha Bach's view because I think he's done the best thinking on this, where he talks about consciousness as a kind of coherence operator. And he kind of flips the script. He says, well, actually, maybe consciousness is the first thing we develop as babies, right? Because we are conscious from our earliest moments, at least from memory, but that consciousness seems integral to our ability to then acquire the skills that then build upon those skills and get us to a high level of agency. So consciousness may come first, not last. And if that's the case, then it may actually be much simpler than people imagine. It may be a product of self-organizing forms of intelligence. We don't come equipped with a trillion parameters, then with, initialized weights. And then, our brain is a self-organizing system that builds upon itself from the inside out. And consciousness from that perspective may be the most natural kind of learning algorithm that is acquired by such self-organizing systems.
Do you think it'll be replicated by AI then? Do you think we will learn to create artificial consciousness for the purpose of learning more efficiently, perhaps?
Yeah, and this is also Yosha's conjecture, is that one of the reasons why current generation models struggle with both coherence and agency is deeply related to their lack of consciousness. And it may be that future systems need to have some kind of proto-consciousness to be as sample efficient as we want them to be, to have the coherence over time that we want them to have as agents.
Interesting. I guess on the flip side, you could also worry that consciousness is computationally costly in some way, and so any system that's conscious would be outcompeted by a system with the same function but without consciousness.
But would that system, so if consciousness is integral to online learning, would that system be frozen in amber?
I think you can get to basically any level of intelligence without being conscious. And I think it's not necessary to reach a certain level of intelligence. I can imagine a superintelligence without any level of consciousness at all.
I can as well, but I think it would, if you want a system that can learn from experience and learn from new sensory data and new inputs, consciousness may be the way you do that. And because we are embodied and embedded in our own inner theater, it's hard for us to step outside and imagine something that's not. But there are, like you said, there are costs to consciousness. People who are very productive at work, we call that getting into the flow state, right? And in some ways, being in a flow state is being less conscious, right? I sometimes can only get into the flow state late at night, where parts of my brain are starting to power down, and I can sort of just lose myself in my work. And I'm slightly conscious, but the fact that I'm so productive is actually due to the fact that my inner monologue and my self-consciousness has dialed down. But on the other hand, if you are a sleepwalker, you have all the faculties, your brain is still there, but you've lost the coherence operator that is letting you act coherently in the world. And so there may be an inevitable trade-off here. And if Yosha is right about consciousness being first rather than last, then it probably isn't that computationally intensive. It's probably just what it feels like to be a unified system that is striving for coherence with a degree of recurrence, and the kind of strange loop going on in how it allocates attention.
What does this mean for AI safety? I guess one worry is that the future will be dominated by just very smart systems that are unconscious, and therefore some form of moral value will be lost. But perhaps if this theory that you're laying out here is right, and consciousness is deeply involved in learning, perhaps there's some future AI systems with consciousness will learn something about morality, something about what we mean when we say pleasure and pain, good and bad. Do you think it would be good for AI safety if consciousness is somehow involved in the process of becoming more intelligent?
I think so. Again, I'm really echoing Yosha on this, where there's a lot of danger in building kind of unconscious golems that can do everything we can do but have no inner light. In part because one of the other forms, a lot of human learning is done through social learning. Arguably most of our learning is done through social learning, through mimicry, imitation, adopting the norms and mores of our peer group. And that capacity to learn is also related to consciousness. This is why we say when you feel self-conscious when you're in an environment that you feel awkward in, because you're sort of attending to your own behaviors and mannerisms to make sure that they match the convention. What that means in practice is that, like, consciousness is integral to our ability to form resonance with other agents, right? When you're in a deep conversation with somebody, you can feel a kind of the boundary between your consciousnesses start to dissolve somewhat. And this is, I think, integral to empathy, right? And why empathy is also related to learning. And if we want advanced AI systems to sort of be in our image, right? And to see themselves in us and vice versa, then they need some capacity to resonate with us on a conscious level. That would be my intuition. And I also just think that, like, if things do go haywire and, rogue AI takes over and like humans are a dead end in the evolutionary tree, I would much rather that new species have consciousness. But this is also, I admit, a chauvinistic point of view.
Yeah, I guess all of this is extremely speculative, but it's still important. I mean, someone has to think about these topics. You write somewhere that if you imagine a future and it doesn't seem like sci-fi, you're on the wrong track or something like that. And this is perhaps what we're doing here. All right. Do you want to talk about AI and children?
Sure.
Yeah. How should we think of having kids if we are on the verge of very advanced AI?
You should still have them. There's a major dearth of kids. Again, I am, showing my cards. I am a speciesist, right? I am a human chauvinist. There's a question, with these questions about whether we should pause or delay AI or make sure that we're civilization is capable for superintelligence. There's always the question of, okay, let's say we pause for 50 years. What are we hoping to gain? What is the world that we want on the other end? What future do we want to build? And who are we building it for? But for another generation.
Yeah, so we want to align advanced AI with the interests of humanity, I think, if we choose to pause. And that's the project we are undertaking during the pause.
Right. And the future of humanity will be our progeny, right? And maybe Richard Sutton wants them to be our AI mind children. But I think there's lots of ways that kind of post-human transition could go terribly wrong. One of the most obvious ways is it just leads to a kind of splintering. We share a lot of cognitive architecture. We share a lot of software and hardware as members of the same species. And this is what enables language games and culture and everything great. Without that common software layer, we'd suffer from, Wittgenstein's private language argument. We wouldn't be able to talk to each other. And there's worlds where, a post-human, the opening of the mere technological possibility of sort of altering our genetic code and adding new cognitive prostheses and having new sensory inputs and so on could lead to totally different kinds of humans that don't share any of that common experience. And that would be a loss. I think it would be a loss precisely because even if you had something that was individually superior, it wouldn't have a shared community.
Yeah, I wonder I wonder to what extent we should protect our children from living in a world that's too far removed from the world we evolved in, where there's too much of this kind of mismatch between our evolutionary psychology and the technology we're encountering. I guess there's TikTok, and you could imagine advanced versions of kind of AI enhanced TikTok. Is that something you want to hand to your child? I don't think so. But on the other hand, you can't hide your child from the world forever unless you want to go the Amish route. So how do we integrate technology into our lives in a wise way?
Yeah, there's a sense in which you could, we already have a rogue AI, and his name is Mr. Beast, right? He is monomaniacally optimizing for the YouTube algorithm and using our cognitive tics to addict children to clicking subscribe because they might win a Tesla, and they never do. But my hope, and this applies to kids and adults as well, an ideal world is one where AI helps us level up in our rationality rather than be used to exploit the foibles and the gaps in our rationality, right? And I tend to think that rationality is not a property of an individual or even a reasoning engine. It's a social achievement, right? We are rational because we have other people, right? Because we have the ability to check each other's biases, to check each other's work, to externalize our cognition into the built environment, and that enables us to be more rational. Someone who has a gambling addiction is less rational than somebody who lays their clothes out, running clothes, before bed so that they can be prepared to go running in the morning, right? And all that but that self-control and that rationality that people achieve is mostly not from their ability to think harder or because of innate factors. There are innate factors that correlate with self-control and so forth, but it really is they have better social scaffolding, right? It's easier to diet if you don't have cereal in your cupboard, right?
There's a person intervening if that person notices you spending too much money on gambling sites.
Yeah, Oprah Winfrey can afford to have a person whose only job is to slap the donut out of her hand, right? And that enables her to be in some level more rational, to have more agency, right? The most competent CEOs have very competent executive assistants and all kinds of social scaffolding around them that makes them more agentic and more in control of their higher order preferences, right? And in some level, rationality is not just can you execute a chain of logical reasoning, but can you align your practical reason, your behavior with your higher order preference? And so I have a piece on the implications of AI for ADHD, for instance, where, I would love to have, as someone with ADHD, I would love to have a super intelligent executive assistant that not only was making sure my bills were paid, but was sort of my tandem partner in work to keep me on track, and to, give me the nudges in a very sophisticated, many hidden layers deep way to make me a better version of myself, right?
You're imagining the kind of AI life coach, assistant, psychologist, all packaged into one model, perhaps. I would like such a thing too, and I would like it to be aligned to my interests, not the interests of a corporation,
but also your specific higher order interests, right? Right, because everyone has their aspirational self and their actual self, right? This was going back to Aristotle, talked about the weakness of will, right? And humans, it would be very easy for AI to pass us in terms of agency because humans have very weak agency. It's very hard. We pay money to go to spin classes, right? Just because it's easier to bike if everyone else around us is biking. And so that collective social achievement of rationality is something that AI could worsen or could undermine or enhance. It could exploit our myopia, or it could build a kind of codex around us to warn us when our myopia is being exploited by someone else.
Yeah, it's a difference between laying in bed, isolated, so scrolling TikTok, and getting a notification from your AI assistant on your phone telling you, here's why you should go to bed early and lay out your running clothes and your vegetable smoothie for tomorrow morning.
Or ideally, the robot does that for you.
Or the robot does that for you. Yeah, that's true. That's true. So I guess your general point is that we should implement technology in ways that make us stronger.
Yeah, just in precisely analogous way that we use a variety of scaffolding to make AIs better at reason, and to be more agentic, we should use AIs to be scaffolding to make us better at reason and agency.
Does it mean that we should avoid simply outsourcing tasks to the AI and to the AIs? And is that possible when AIs are increasingly better than we are in many domains? How do we avoid saying, say your child comes to you and say, why do I have to learn calculus? This AI is much better and will always be much better than I am at it. Why do I need to learn something? Does education and self-improvement become more of something you do for its entertainment value? Yeah, what's the argument there?
It's a good question. I mean, we already have surveys where kids would rather be YouTubers than astronauts, right? So depends on what you want to achieve. Is there really a lot of value in learning calculus? I think that there's value in understanding, the first fundamental theorem of calculus and understanding some of the more conceptual parts of math, but you don't necessarily need to know how to grind out, partial differential equations.
That's true, but I guess the generalized form of the argument I'm trying to make is just what is your answer when your kid asks you why he should stay kind of informed and active in the world and trying to hold on and understand what's going on, if it's so much easier to simply outsource tasks and goals to AI systems.
Maybe they shouldn't, right? I think we have a kind of conception of the liberal arts and humanities and what it means to be an informed citizen. I think this is part of the aspirations of our current technological regime. 500 years ago, what mattered was, did you honor your mother and father? Did you work hard, and did you follow the right liturgy or something, right? And insofar as if AI does lead to a kind of balkanization and relocalization and kind of more communitarian world, then I think there won't be just one sort of right way to interact with the world. I think we'll have more deep diversity, right? We'll have different conceptions of the good, and ideally, this is, not just that you have a high score on Clash of Clans, but that you are being fully human, right? That you are touching grass, that you're forming relationships and living the Shakespearean tragedy of life, rather than just having everything drone delivered to you.
Mm-hmm. Okay, last question. Should we accept relationships, friendships, or romantic relationships between AIs and humans?
We should tolerate them, whether we should accept them. Again, this goes to whether we use AI to enhance our rationality or to exploit the weaknesses in our rationality. And the long-term answer to this won't be simply passing a law saying you can't have an AI girlfriend. It will be building better tools that make you a better person so you can go get a real girlfriend. And so, this is, again, one area, sort of differential. Maybe the D&D Act should be dating life.
That's good. Okay, Sam, thanks for talking with me. It's been a real pleasure.
As always, thanks, Gus.